Open source is technology neutral, and that means you can use open source software with any devices or technology. Well done! You've made it to the last lesson in our second course. You are a rock star and part of our community. Congratulations! Now that you've learned all 10 points in the open source definition, we should definitely have a party to celebrate. I know! Let's have a disco. Oh, I love to dance. Oh, and we can have 99s too, since it's a party. Through the 10 lessons, we've discussed 1 point or definition in each of our lessons. What we've learned is that open source is set out in the open source definition, looked after by the Open Source Consortium. And it's for all of us to use and reuse, to contribute to and to modify. And that open source is available for everyone without discrimination amongst people or across their activities or technologies. Of course, open source software also needs a license. Do you remember that we gave an approved OSI license for the code, as well as the code meeting the open source definition? We've also learned a little about sustainability and that open source is based on principles of collaboration and reuse and collective equity, which promote the Sustainable Development Goals. Open source software can be reused and recycled itself, but using it also encourages us to maintain software and to fix bugs, which make other technology and our devices last longer. This is part of our circular economy. If we fix bugs, we replace devices and equipment less, and that uses up less of the Earth's resources. Even the Sustainable Development Goals were built using open collaboration, open source software and open data. I like to listen to music and stream it from my device so that I can boogie on down. I use the internet to stream my music. Do you? Maybe we can use our gloves to create a disco. Yes, let's do it. We use the World Wide Web, which Sir Tim Berners-Lee created in 1989 to access our music online. Sir Tim created standard protocols, the HTTP Hypertext Transfer Protocols, which have evolved over time into the web we know today. The web's an open technology. No surprise there then. And, like a lot of the code we've already learned about, it has a foundation looking after it. This one is called the World Wide Web Consortium, or W3C. And yes, you can learn more about the W3C in the e-zine. The web is an information system where documents, images and, oh yes, my music can be found on web pages. You already know that we locate these on our devices using browsers like Firefox. We identify the pages using the page's URL. That's Uniform Resource Locator. Tim Berners-Lee also created the first web browser in 1990. Tim was a busy guy. No discos for him. We've also learned a little about servers. They serve up our web content to the computer so that it can be read by the browser. Standards are important and are explained in more detail in the e-zine with this lesson. They allow us to use the same measure or rules of behaviour in our activities. It's a bit like us all dancing in the same direction with our gloved hands in the air, waving them left to right as we make music. Although standards are not laws, but voluntary and help us to make our technology work efficiently. If a web page goes wrong, it's often because the standards are not being followed, a bit like someone not following the dance routine. Can you imagine a world without the web? Maybe your parents or grandparents remember one. It was very different. No online shopping, no social media, no gaming with our friends, and no streaming music for a disco. Let's use our gloves to create a disco. In this lesson, you will learn that open source is technology neutral, about the importance of the World Wide Web, how to make your own custom blocks in MakeCode with JavaScript, to use another coding language, JavaScript, Have you ever wished you could create your own blocks in MakeCode? Maybe you want to do something, but there isn't quite a block for it. MakeCode has a handy trick that allows developers to create their own blocks. Today, in our final lesson of Series 2 of the OpenUK Kids course, we're going to show you how to create a funky new disco block, which will allow us to create a party glove which flashes as we move and dance. Perfect for our disco. Now, this could be a bit tricky, but don't worry. We'll give you all the code you need. We're also going to dip our toe in the water with a new coding language, JavaScript, as well as MakeCode. Woohoo! You're flying through learning to code, right? Let's start off by heading to openuk.uk/openkidscamp/text files to download a text file to your computer and head to the MakeCode editor. The JavaScript code required for this lesson is inside the text file, and you'll need to copy and paste it into the MakeCode editor in a little while. This time, we're going to be using a language called JavaScript. JavaScript is a text-based language, just like Python. JavaScript is used in many different situations. A particularly common use for JavaScript is to make web pages interactive. Did you know that JavaScript is the only programming language native to the web browser? Developers say that word, native, when they mean it's created for something and not for general usage. So JavaScript is native to or created for use in web browsers. We're certainly learning about the World Wide Web today. We are programming the microbit using both JavaScript and the MakeCode blocks in this lesson. So let's start by switching to JavaScript. We do that by clicking the button called JavaScript at the top of a new project in the MakeCode editor. You can find this at https://makecode.microbit.org/. Then we want to click on the Explorer button below the microbit simulator. This should open up a drop-down menu with a whole bunch of files ending with .ts. See that grey plus button next to the Explorer? Go ahead and click it. A confirmation block should appear. Now, press Go Ahead, and you'll be one step closer to making our very own custom block. We're now in the custom.ts file. Here is where we can create new custom blocks. Scroll to the bottom of the file and copy across the JavaScript on a new line. Your code should look something like this. Notice how there is a few blank lines. Those are where you're going to be writing code. Okay, so you've copied your code across, but what does it do? Let's talk through it line by line and see if we can make this tricky bit of code a little less daunting. First up, what does namespace disco mean? Well, a namespace allows blocks of your code to be grouped together. This means they're easy to find and identify. This will create a category like basic and input and music called disco. This will make finding our new custom block easy to find. The next line is a comment. Notice how it's in green. The microbit will simply skip over it, but it's useful for us developers to know what's going on. Funky disco lights and sound. Sounds exciting to me. I can hear the music. The next line tells the microbit to turn our JavaScript function into a new custom block. Export function plus the name of our function, disco, plus some brackets, plus void. The brackets are empty because our function takes no input parameters. You need to write this next line. We're going to want to create a new variable called frequency. The way to create a variable in JavaScript is let plus the variable name. Then an equal sign and the value of the variable. We'll write this line on the blank line below, the Add Code Here comment. Let's set frequency equal to 262. Next, we'll create a loop. we want our loop to repeat 4 times. To do this in JavaScript, we create a new variable called index and set it equal to 0. Every time we go around the loop, we'll increase the value of index by 1 until index is equal to 4. So the first time around, index is equal to 0, then 1, then 2, then 3, so in total it loops 4 times. We're going to write this code in the round brackets next to the word for. First, we create our index with let index equal 0. We then have a semicolon to separate this from our condition. Our condition in the index is less than 4, so write index, then the less than sign, then 4. Finally, we want to increment our index variable. Do this by writing index, then 2 plus signs. So that's our loop. But what happens inside the loop? This code makes all the LEDs in the LED screen turn on. Woo! Disco lights. Loving it. Do you notice how it's basic.showLEDs? This means it does the same as the show LEDs block in the basic section. The function has one input parameter, which is the next part in red. This says which of the LEDs in the screen should turn on. We use the hash symbol for on and a dot for off. I love how neatly the hash symbols are organised. We can see exactly which LED they correspond to, as every LED has a hash symbol. Every LED will be turned on. OK, so we've got the lights, but hey DJ, I said, hey DJ, where's the music? Unfortunately, this DJ's a bit rubbish. They only play a single note. We're going to type in this line. Be careful. Just like Python, JavaScript is also fussy about punctuation, spelling and capitalization, so make sure your code looks exactly like the code here. To play a note, we're going to want to write music.playTone. This does the same thing as the play tone block in the music section. This function takes 2 inputs, frequency of the note and the number of beats that it sounds for. Beat fraction.whole means a whole beat and frequency is just our variable, which we created above, which, first time around the loop, will equal to 262 Hz. So, we've got the music and the lights turned on, but it's a bit boring if we've left the lights on. Know what I mean? So, let's turn the lights out. It's the same code as before when we turned on the lights, but now we've got all dots instead of all hashes, so all our LEDs will turn off. Finally, you'll need to increase the frequency so that next time around the DJ plays a slightly higher note. They're not the best, DJ, but they are getting better. We do this by typing frequency equals frequency plus 30 on the line below our show LEDs code. We could create the same thing using a combination of blocks and functions in the block editor, but making our custom block here means it's a lot shorter, as we now have one block instead of several. Custom blocks are great for making lengthy block code shorter, but the written code is still quite long. Click back to the blocks editor. We now have some new categories. If you don't see your custom blocks in the palette, try pressing the refresh button of the browser, and it will load your new custom blocks properly. In the new categories, one of them is our disco category. It contains a single block, our disco block. But hold on a minute, another category has also popped up called custom. Take a look inside and you will see a few other blocks called fib and foo. We didn't create those. But if you look back inside the custom.ts file, we have code pre-written. The namespace here is custom, and we have our 2 blocks, fib and foo. Fib computes the Fibonacci number sequence. You know the one 1, 1, 2, 3, 5, 8, and so on. As for foo, if you look in the custom.ts file and find where the foo block is created, you'll see it doesn't do anything. It's just an example of how to create a custom block. Right, back to the block editor. Now that we know what our custom disco block does, you can use it in a simple program to create our party glove. Drag our disco block into an on-shake block and flash the program to the microbit. Now, if you decide to make any changes to the JavaScript code, you'll have to refresh the browser in order to reload our custom blocks. Have fun dancing at the disco with your party glove. In this lesson, you've learned that open source is technology neutral, about the importance of the World Wide Web, how to make your own custom blocks in MakeCode and JavaScript, to use another coding language, JavaScript. Maybe after this, you might like to try creating your own custom block. You can really start to experiment now that you have so much experience. Maybe take some of the ideas we've shared with you and mix them together, modify some of the code, and make it your own. The main thing is to have fun with the code. Oh, and to be mindful of the SDGs and keeping our planet safe for the future as you do that. That's what being an open source developer is all about, using your ingenuity. Ingenuity is also the name of the helicopter NASA sent to Mars. It uses open source software, including Linux, to fly its mission there. Lots of people contributed to the code from all over the world via the web by sharing code on GitHub. Maybe you will do that too someday using your ingenuity. In the meantime, enjoy the disco and take a look at openuk.uk for more learning resources and opportunities. See ya!